Good evening everyone and welcome to the Q&A session 9 from the playlist of System of Particles and Rotational Motion. The topic is the equations of rotational motion, and based on this topic I have selected one question for this session, and we will discuss this question after discussing the equations of rotational motion. So जैसे कि linear motion में there are three equations for constant acceleration, and those three equations are v is equal to u plus at, then s is equal to ut plus half at square, and then v square is equal to u square plus 2as. Now here v is the final velocity, u is the initial velocity, a is the acceleration, and t is the time. And here s is the linear displacement. So these are the three equations for the linear motion having constant acceleration. So उसी प्रकार से there are three equations of rotational motion having constant angular acceleration. So वो equations कौन कौन सी हैं वो मैं यहाँ पे लिखूंगा. That is, the first equation is omega is equal to omega naught plus alpha t. So now this equation is comparable to this equation, that is v is equal to u plus at. So here in the case of rotational motion, omega is the final angular velocity, omega naught is the initial angular velocity, and alpha is the angular acceleration, and t is the time. इसी प्रकार से there is the second equation is theta is equal to omega naught t plus half alpha t square. Now this equation can be compared to this second equation. Now here s is the linear displacement, so here theta is the angular displacement. Omega naught is the initial angular velocity. So in the case of linear motion having constant this linear acceleration, so in the case of linear motion having constant linear acceleration, u is the initial velocity. It is the initial linear velocity. And in the case of rotational motion, omega naught is the initial angular velocity. Again, t is the time. Alpha here is the angular acceleration. In the case of linear motion, a is the linear acceleration. So this is the second equation for the rotational motion, and the third one is will be equal to omega square will be equal to omega naught square plus 2 alpha theta. Now here this equation can be compared to the third equation of this linear motion having constant linear acceleration. So यहाँ पर क्या है? Omega naught is the final angular velocity. Omega is the final angular velocity. Omega naught is the initial angular velocity. Alpha is the angular acceleration. Theta is the angular displacement. Now here in this equation, v is the final linear velocity, u is the initial linear velocity, a is the linear acceleration, and s is the linear displacement. यहाँ पर linear displacement s है, and in the case of rotational motion यहाँ पर angular displacement है, that is theta. So these are the three equations of rotational motion. So we will be using these equations in order to solve this question. So in this question there is a wheel which is subjected to uniform acceleration about its axis. Initially its angular velocity is 0. So omega naught is equal to 0, and this wheel is subjected to uniform acceleration. Now since this wheel is rotating about its axis, so here angular acceleration here is given is uniform, and I will just write it here that alpha is uniform acceleration, and in the first 2 seconds it rotates to an angle theta 1, and in the next 2 seconds it rotates to an angle theta 2. So we have to find the ratio of theta 2 divided by theta 1, and there are 4 options there. So the option 1 is 1, option 2 is 2, third option is 3, and the fourth option is 4. So let us take the first case. In the first 2 seconds, it rotates with an angle theta 1. So here the angular displacement is theta 1, and this will be equal to, here the initial angular velocity is 0, omega naught is 0. So I can use this equation, that is the second one. So here omega naught is 0, so theta 1 will be equal to 1 by 2. And here I have taken this angular acceleration, which is uniform in this case, as alpha. So this is equal to 1 by 2 into alpha into t square. Now t here is 2 seconds. So this will be equal to 2 square, and this will be equal to 2 alpha. So theta 1 is equal to 2 alpha. Now let us take the second case. In the next 2 seconds, it rotates with an angle theta 2. So we can say that in the first 2 seconds, it has rotated through an angle theta 1, and in the next 2 seconds, it has rotated through an angle theta 2. So the total angular displacement कितना हो गया? Theta 1 plus theta 2. So in the second case, the total angular displacement will be equal to theta 1 plus theta 2, and the initial angular velocity is 0. So I will be again using this second equation, this one. This omega naught is 0, so this omega naught into t will be 0, and this will be equal to 1 by 2 alpha. Now t, now here the t, the value of t will be equal to 2 plus 2, that is equal to 4 seconds. So this will be equal to 4 square. So this will be equal to 16 divided by 2, which is equal to 8 alpha. So this is the first equation, and this is the second equation. So from these two equations, I will be able to find the value of theta 2 upon theta 1. So from now theta 1 is equal to 2 alpha, and theta 1 plus theta 2 is equal to 8 alpha. This is from the equation number 2. So theta 2 will be equal to 8 alpha minus theta 1, which is equal to 2 alpha, which is equal to 6 alpha. So it implies that theta 2 upon theta 1, this will be equal to 6 alpha upon 2 alpha, and this is equal to 3. So the correct option will be C, that is theta 2 upon theta 1 is equal to 3. So thank you very much for joining this session. In the next session, I will be coming up with a different type of a question from the topic of the rotational motion, and that question will be pertaining to the topic of angular momentum. So till then, have a nice day. Bye.